Okay, so let's talk about power. Alright. And just as a side note, power dissipated determines the brightness of the bulb. Okay, so power is what gives us bulb brightness. And power is defined as current times voltage. Okay? Remember, current in amps, which is coulombs per second. This is volts. Remember, volts are joules per coulomb. Let's write this down. First off, what should power be? What units?
Joules per second.
Joules per second, which is watts. Okay? So power is equal to I times delta V. Alright? So we know units of power, that should be watts. This is amps, and this is volts. You can rewrite amps as coulombs per second, right? And this is going to be joules per coulomb. Joules per second, that's a watt. Okay, so the units work out. The units of power are watts. Now when you read a light bulb, when you buy a light bulb, what does this tell you?
Input power.
Input power, output power?
Output.
Which one are you going to care about?
Output.
Which one do you pay for?
Output.
How does your power bill work?
Damn. How much you use?
How much power comes in and you use. So it's the input power. It's how much power the light bulb uses. Okay? So if you buy an LED bulb with the same brightness, okay, it's going to say 60 watt equivalent brightness. But how many watts is it using? Less than 60 watts. Okay? More efficient bulbs can get the same brightness with less power input. Okay? So, brightness is measured in lumens, which is something when you go shopping for bulbs at Home Depot is useful to. And incandescent bulbs were the thing. You're like, okay, is it 40, 60, or 100? All right? Now, if you want something that's like a 100 watt bulb, it's not going to be a 100 watt bulb, which is good because you don't want to pay that much. Okay? So, for this brightness, right, this is your standard light bulb that we all used like a decade ago when light bulbs were inefficient and they could start fires. Okay? So this is 40 watts, this is 60 watts, 75 watts, 100 watts. This is the actual brightness in lumens, which is a different unit. Okay? So this is going to be 1600, this is 450. Okay? So if you want equivalent bulbs, so if you have halogens, all right, the same output as a 40 watt bulb is now 29 watts. All right, same output as a 40 watt bulb in compact fluorescence, 10 watts. Okay, same output of a 40 watt bulb in LEDs, 5 watts. Okay, so that means you used to be paying $5 a year to run this bulb. Doesn't really say how. Also, incandescents can burn your house down. Like you put something on top of the bulb, they get really hot, right? If you touch an LED, it's not hot. Now, what does that tell you? How are these things using energy?
Doesn't generate heat.
Doesn't generate heat. So you're saving the money because you're getting light. You don't have to spend a bunch of money for something that also generates something you don't want. Okay? You don't want your light bulbs to be hot, but these are bright and hot, okay? Because the mechanism of an incandescent bulb is to heat up a filament so hot that it glows. It gives you a very nice spectrum, similar to the sun, but you don't necessarily want the heat of the sun in your lamp. Well, no, it doesn't give you, it's not in the UVs. Yeah, that's actually black body radiation, right? Heating up something so hot that it glows. Right? When your stove, if you have an electric stove and it glows red, okay, it's emitting black body radiation. You can tell by the color of the stove what the spectrum of radiation is that's being emitted. Most of it's infrared, okay? Okay, so anyway, this is why LEDs are much more energy efficient than the old incandescent bulbs, and also slightly less of a fire hazard. Although LEDs are much more complicated from a circuits perspective, okay? These are really simple. It's a wire connected to a filament, connected to another wire in a glass vacuum. Simple, okay? All you do is you run current through the wire. When it goes through this tiny filament, it gets hot and it glows, okay? That is super easy to understand. LEDs, a little bit less. I don't know, what if you want a reading lamp?
Tomatoes.
Okay, so power delivered by a battery, okay? That's just going to be current times voltage through the battery, all right? So it's the current of the battery and the voltage across the battery that gives you the power output by the battery, okay? If you want the resistor, it's just the current through the resistor times the voltage of the resistor. So you have to calculate the power for each circuit element, okay? And then you could calculate the power for the total system. Basically, if you have a battery, that's the power output. If you have, it should be the same as the power used by all the other circuit elements, okay? Now, for a resistor, you don't always want to do this in terms of voltage because you may not know the voltage of the resistor. You'll usually know the resistance and the current. How do you go from this to these? How do you get rid of delta V? Equals IR. Okay? So delta V equals IR. Just plug in IR, and now you have I squared R. Okay? If you want to get rid of I, delta V equals IR. I is now R over V. Now you have something that looks like this. Okay? So these are all the same statements, but